Hello, everybody, and welcome to the 26th episode of Tech Life Skills with Tanmay. My name is Tanmay Bakshi. Thank you for joining me today. And today we're going to have a lot of fun once again. Now, that's because on today's show, we're actually doing another student special episode. And this one's a little bit different from the ones that we've done previously. We actually have two students on the show who are both recent graduates, but both in very different ways. So it's going to be a really interesting discussion. Now, one of our special guests today is a recent high school graduate who's passionate about the intersection of business and technology. She's also the program director at Startup Dojo. Her name is Anjalee. And our next special guest is a recent graduate of the University of Toronto in the Industrial Engineering program. Her name is Meaghan. And so now, without any further ado, I'd love to welcome our special guests to the show. Hi, Anjalee. Hi, Meaghan. How are you?
Hi, I'm good.
Hi, I'm so excited to be on the show.
Thank you. I'm excited to have you on. Excited to see what you have to say about the world of technology, what your experiences have been like, and so on. But first of all, though, before we get started, I think it would be really interesting if the two of you could just quickly introduce yourselves. How about we start with you, Meaghan? You can just quickly introduce yourself, tell everybody a little bit more about the work that you do, and then we'll get started.
Yeah, of course. Thanks, Tanmay. So as you mentioned, I'm a recent graduate from the University of Toronto with a degree in industrial engineering. Throughout my degree, I had the opportunity to study abroad in both Sweden and South Africa. And as you mentioned before, I've had the opportunity to do tons of fun projects, some of which include jump detection for snowboarders and also studying the communication patterns of designers during 3D CAD. In terms of tech experience, because this is a technology show, I've done a few different tech internships at both big tech companies and banks. Right now, I'm currently working in technology at RBC.
Very nice, very nice. Finance and banking, that's a theme that I'm seeing. So we'll get to that in just a moment, see why you're so passionate about that. But also, Anjalee, would you like to quickly introduce yourself as well?
Yeah, definitely. Thanks again, Tanmay. Hi everyone. My name is Anjalee. I'm a recent high school graduate. I'm really passionate about tech. I started coding when I was like 10 years old, and from there, my team and we became Vex Robotics World Champions in high school. So I've been really passionate about tech my entire life. And right now I'm really passionate, especially about the intersection of business and tech and how I can use my positive experiences and opportunities to help other students. So I run a podcast called The 2020 Show where I talk to awesome tech founders and entrepreneurs. And as Tanmay mentioned earlier, I'm also program director at Startup Dojo, where we help teach entrepreneurship and spread that passion for tech and innovation.
It's very nice. I feel like what's really important is that it's nice for the next generation of developers, of course, to be passionate about technology. But what I like even better is that you're passionate about, enabling others to use technology as well, right? I feel like that's really important. And also being able to make that technology that they create, once they're interested in it, accessible through, the intersection of business and tech. So, I mean, that's some really interesting stuff you're working on, and we'll get to that in a minute. But I first want to ask, and this is actually I think pretty interesting. Why do you work with technology? Like, what initially sparked that interest of technology with you? What was that first sort of moment where you were like, oh, I actually want to work with technology? When did you realize you were passionate about that? Maybe we can start with you, Anjali.
Yeah, that's a great question. If I had to pinpoint a moment, I think it'd have to go back to um, the moment where I really decided that this was something for me was probably when I was like 10 years old, introduced to this competition called the First Lego League. So for those who don't know, it's like this little competition for kids where you make these robots out of Lego, right? And you compete with them, and it's this whole thing. It's really fun. Um, so I was really fortunate because my elementary school happened to offer that, and for some reason, myself and a few friends were pulled in to be on the first team. So that was interesting, but I didn't really decide. I didn't really hit that moment where it was like the tech is the thing until the competition. But this story is not going in the direction you expected. So at the competition, we're a bunch of really excited kids, and we come in last place because none of us have any clue what we're doing, and we come in last place, dead last place. So it was this crazy experience for me as like a 10-year-old being like, this thing is cool. And I know there's so much to improve on, like personally, and I'm so excited by even though it was painful, of course, it was painful losing, but I'm so excited to figure out how I can get better So it's kind of that, that initial loss and the desire to learn more that kind of really pushed me into it.
The reason that I like that story so much is because a lot of people, you think you get last place, you're so demotivated, you're like, no, I don't want to work with this anymore, right? But it's nice to hear that motivated you to learn more about technology, right? That's a good twist to it. That was really interesting. What about you, Megan? What sort of initially sparked your interest for the world of tech?
I think definitely I started a bit later than you. My first exposure to tech, I think I would have to say would be first year university. So a stage that you haven't even reached yet, Anjali. So I'm impressed by like how long you've been doing. You've been doing it much longer than me. Um, but I think I've always loved science. I've always loved math and like problem solving. And I think coding, especially I guess like with my peer group who I was talking to, it seemed like this like crazy scary black box. I didn't know anything about it. I was like, how do you be a coder? I'd only really seen like hackers on TV. Like I didn't have too much exposure to what programming was. A terminal looks very, very scary. So I think in first year it really pushed me. We had a first year programming course. It was like I remember the first lab being so hard. I was like, I don't get why you're assigning a variable like x equals 2. Why are you making x equal 2 just to add 5 to it? I didn't get it. But then it just clicked somehow. And I realized that technology, coding, just like that whole world, there's so much you can do with it. And it's just problem solving, but problem solving in the best way because you can apply it to pretty much anything. And I think that's the moment when I realized how powerful tech was and also how cool tech was. And I think just being comfortable with programming, being comfortable with that realm kind of made me a little more comfortable with adventuring further into tech.
That's
Yeah.
uh, yeah, that's so interesting to hear that initially you were kind of like not necessarily afraid, but like
Hmm.
you didn't enjoy that concept of technology, right? You had these misconceptions as to what programming was all about, right? It looked like that black box and how you were able to sort of peer into it with that experience that you got at university. And I feel like that actually points to something that I talk about quite a bit, and I feel like, your sort of story actually proves that, and that is that, it's always possible that you're passionate about something like technology, but you don't know it until you get the experience with it, right? Until you
Hmm.
have the opportunity to actually work with it, it's hard to find out that you're passionate about something like technology or really anything, right? So it's good to be able to, get a wide variety of experience when you're young so you can figure out what it is that you want to do. As a matter of fact, actually, what you mentioned about coding being so, problem solving centric and being so almost creative in a way, which is something that I want to talk about with the two of you in a moment as well. Um, I feel like programming is, in a way, oddly natural, right? Different pieces fit together really, really well. Kind of like with language, right? When the first humans, as we invented language over many hundreds of years, right? We didn't sit down and write syntax trees and rules for grammar and things like this. We had language, and that was just the way our brains were structured, right? Humans are built to communicate in natural language, and just a couple hundred years ago, I believe. I'm forgetting his last name, but it's William, and then I forgot his last name, put together the first sort of rule book of grammar for English, right? So just like how natural language is almost built into the way that we think, I feel like programming languages are also incredibly intuitive and tie into our creativity. And one of the examples that I actually love is I remember a long time ago when I was learning technology. This is back when I was like 7 or 8 ish. Before I started working with like iOS development. Back when I was doing like Visual Basic stuff. I remember one of the questions that I asked my dad, since he used to work as a computer programmer. One of the questions that I had asked him was, "Sure, I can have variables, right, and I can have arrays and these things. But what if I wanted to take input from the user and use that input as the name of the variable?" And I didn't know it at the time, but the concept that I was getting at was dictionaries, right? So these pieces fit together so naturally that even though I didn't know what to call it at the time, I knew that something like this would have to exist for certain use cases to be possible, right? So things just fit really naturally, I feel like, and they tie into human creativity. And as a matter of fact, something that I want to ask the two of you really quickly is that traditionally, people that I feel like don't work with technology as much have this conception of programming being such an analytical or structured activity, right? They don't think of it as a creative task, something where you're, trying to invent novel solutions to problems. What do you have to say about that? Do you agree that programming and working with tech is more creativity than, analytical, mathematical thinking? What do you think? I mean, either one of you can start.
Yeah, I think that's. Go ahead.
Oh, okay, thank you. I was going to say, kind of just jumping on that point of language and rules, just like the English language has its own set of rules and has its own set of rules, so does programming. But English, I don't think you would argue that writing is not creative. Like plays or novels or stories, like, yes, the basic building blocks are very structured, but I think what you do with that is amazing. Even like building buildings, like bricks themselves, are very structured, but then you see some buildings built with that and they're so creative. I think programming the exact same way. It's just another language that can be creative. I think that, yeah.
Yeah, I think I completely agree with both of things, both what both of you have said. Like, when you write, of course, that's creative. There's nobody's going to dispute that and trying to convince you that writing is some sort of analytical thing. And I think because like there is some level of logic embedded in coding, people just only fixate on that piece and they completely forget that you're making stuff. Why do we have this logic and these rules? They're here so that you can use the logic and the rules to make things, and that is inherently creative.
That is, I feel like that's a great way to put it, right? Because why is technology here? Why do we have languages that enable us to represent computational logic? It's so that we can build things, and that's where the creativity comes in, right?
Right.
Like, we have GPT-3, and tell me if you've seen this, GPT-3 writing code for people automatically, and people are like, oh, we're going to be able to replace developers now because we can describe applications in natural language. But what people aren't realizing is that's not real code, right? That's just giving an exact description of what a UI needs to look like, and GPT-3 is just going in there and manually translating what you've already thought of, right? That creative process has already been done, and now that's being translated to code, right? The logic isn't being invented by the network. So it is a pretty creative job, right? I mean, even as you write, the creativity is not the fact that you write the language. The creativity is what you think of, the thought that that language backs, right? And same thing with technology. It's all about that creativity of what is it that I want to implement. Now, we've talked a little bit about building things with technology. What kind of things have you built with tech? I want to know, what sort of projects have you worked on? Why are they interesting? What do they do? Maybe we can start with you, Anjalee.
Yeah, so in terms of notable projects, so I mentioned how I started on that robotics team when I was really little and then kind of stuck with it. So after that big loss, I stuck with it. And then eventually I ended up in this bigger competition called Bex Robotics. Mm-hmm. So there are over 20,000 teams across the world. You build these big metal robots now as opposed to little Lego ones. So I was a part of that. And we did some pretty interesting things. So our team developed essentially like a positioning system. So for those who don't know, the Vex competition happens on this big kind of mat, right? So there's a mat and there are challenges and things that you need to get to. Like some years you might need to shoot balls at targets and pick up a thing here, move it there. And there's a big autonomous section where you're like, okay, here's the field, score as many points as you can. So normally the approach to doing that is just like hard coding. So like go here, move how many inches forwards, or like until you sense a thing, do that, do this. But that's very open to error, right? Like error will slowly accumulate over the course of the run because these like there's fuzz in the sensors or whatever. So what we developed was this thing where we had 3 little wheels that we stuck into the ground, and all they did was track motion. And using this, we were able to like calculate where the robot was and position it, and develop like a sort of coordinate system on the grid. So instead of saying move how many inches forwards, we can say go to this specific coordinate. And that was really cool because we were able to make this really, really accurate system, and it ended up like publishing like documents for other teams to kind of do this, because that year we won like internationally because we had this really cool system that we developed. So that was really cool.
Very nice. The motivation you got from that first Lego competition really drove you to innovate. And see, that's exactly what I was talking about, right? With the creativity to think, how can we do this differently, right? It's already been done this way. How can we do it differently? I feel like that's really incredible. Now, Speaking of error accumulating, something that we're going to be talking about in a future Tech Life Skills episode further is going to be language modeling. As a matter of fact, actually, there I have another talk on it actually in 2 days on Tuesday, so I'll put a link to that in the description. But anyway, language modeling where error accumulates as language models write, right? Like for example, GPT-3 again, right? You take a look at how GPT-3 can write natural language. We take a look at, for example, the Guardian's article on this article was written by artificial intelligence, where they used OpenAI's technology to write the article automatically. If you read through, you'll notice that there are certain points where GPT-3 almost kind of forgets what it was talking about. And it puts in one word by mistake that it doesn't know how to recover from because it wasn't trained to recover from errors, and just sort of spirals out of control. So we'll get more into AI and machine learning, and if either the two of you work with that technology in a moment. But first, Meaghan, though, I do want to hear more about your projects as well. What kind of stuff have you worked on?
Yeah, so I think the one that comes to mind the most is my final year thesis at U of T. With that, it was really my first experience getting into the realm of academia, which I think is so interesting, and I can get into that in detail after. But this project, what we did is I worked with a group of students in a lab, Ready Lab, with Professor Allison Oliowski, and we really wanted to see how designers worked using 3D CAD. And different students did different pieces. There's a PhD who that was his main thesis, but my little part was studying the communication patterns between these designers. So I had the opportunity to help facilitate these experiments. They were in-person experiments. We had 2 to 4 people in a room working on the computers, doing the CAD designs, and then afterwards I got to analyze the data. I got to work with the data from video form all the way to transcribed, doing a little bit of basic sentiment analysis on that. I think following it all the way through the pipeline was really interesting. And also, if I guess I've kind of alluded to it before, but my experience with technology is very focused on software and programming. So I think getting exposure to how CAD works, how 3D design works, that aspect of tech, especially when it comes to mechanical design, is so interesting. And also just also being able to use technology to study something like communication patterns, which traditionally would be a little more social sciencey, so interesting. So I think with that, being able to work with the data from the very beginning, so from video form extracting the audio to then being able to find something usable and have results from that, and then also working in a bunch of different fields, especially ones I didn't necessarily have as much experience, was so interesting. And just the scope of it was at least for me as a student, you have a very narrow scope. This is your project, this is your data, so I could work with that. That was one of my big projects where I liked how big and broad it was.
Very nice. And specifically, actually, follow-up question, were you specifically sort of fascinated, or did you enjoy the fact that we could, I mean, you already sort of mentioned it, but that we could understand, for example, natural language and do sentiment analysis? Was that of any particular interest to you, the fact that you can use technology to automatically figure these things out?
Yeah, I think it's definitely very, very interesting. I definitely intend to look more into sentiment analysis. NLP is a super interesting field. I know it's super big. You've talked about it a lot as well. Yeah, that definitely piqued my interest, I think.
Yeah, because the reason that I ask is because, I mean, back when I was 11 and I sort of first got into Watson and these sorts of things, that sort of almost re-sparked my interest in technology. It was sort of, it was there before that, but it wasn't as great as it could be, because I was like, technology is great, but the most we can do with it is give it rules, right? Very explicit rules, and that's very limiting, because we can't do things like sentiment analysis or understanding natural language or so many other things that we just couldn't do. And when I saw that, we have these AI machine learning capabilities, I was like, that's incredible, right? That can change the way that we use technology, and it has, right? Everything that we do is powered by AI in some way, or machine learning. After this video is uploaded to YouTube, YouTube is going to use a machine learning algorithm to transcribe it into subtitles, right? So now people, that can't hear the video properly can use subtitles automatically, and it's incredibly accurate. So I think this technology is really incredible. And again, we will get into that more in just a moment. Before that, though, I do want to take up a quick question from the audience. This one's from Shiva on the live chat. She's asking, working individually with tech or in a team and as a collaboration, which one do you think is the best way to work, and how much do you enjoy either way of working with technology? So individually or in a team. Maybe we can start with you, Anjali.
Um, yeah, I think each has like I think it's fun either way. Like I enjoy working with people and like in a team setting you can brainstorm new ideas to solve problems in ways that you probably couldn't have come up with on your own. And this really touches back on that idea of creativity we were talking about earlier. Because there's a lot of creativity involved in trying to developing the idea of what you want to code, that there's so much creativity there. And like one mind alone, you'll have some ideas. But when you're with other people, you can build off of it. You can figure out, oh, that piece is really cool. Oh, that piece is really cool. And like form something even better than you could have imagined.
And Megan, any thoughts?
I think Anjali makes a really good point that when you work with other people, you can collaborate. You definitely like, if you have an issue, you're not limited by just yourself. You have other people to lean on and work with. I also feel like programming as an industry is so collaborative. Everything is going towards open source, and even though maybe you're not located in the same location, I feel like programming, though traditionally it seems to be a very isolated thing, you think of people in their basement just coding by themselves. I think it's becoming a more and more collaborative career and a collaborative job. And I think that's really positive. I think you can only gain from being more collaborative. So
Absolutely.
I so I think to answer that question, I would definitely go towards the team versus themselves. But that's also just like my personality. Like I tend to prefer working with people.
Yeah, that's understandable, right? Everybody has their own preferences. Shiva says, I prefer to, practice alone, but, everybody has their own sort of way of working, and that also affects, what you would be doing with technology, what kinds of things you work on, right? Like, I mean, open source, I think, is the greatest example of this. We could not have toolkits like TensorFlow if it was even forget a single developer. We couldn't have toolkits like TensorFlow if there was a single company working on it, right? It has to be open source. So we have Google, IBM, Microsoft, even Apple, everybody working on making it better for everybody else, right? We kind of need that innovation. And I loved your point, Anjali, about programming being creative and therefore inherently benefiting from having a team, right? Like something that we traditionally associate with creativity would be things like, writing or maybe songwriting, right? And you take a look, I pulled up some literally completely random song right now. There's 7 songwriters on it, right? And that's, with more people working on that inherently creative task, you have, this wider pool of brainstorming knowledge to be able to pull from, right? And same thing goes for programming, I think. We have lots of different people with lots of different ideas working together. We end up getting a better result. As a matter of fact, speaking of collaboration and teams, I know, Anjali, that you are the program director at Startup Dojo. So I want to know more about what Startup Dojo is. What are you trying to do with that venture? And can you just tell us a bit more about that?
Yeah, so at Startup Dojo, we believe that. So this is kind of a bit of a, a sidetrack from tech strictly, but we believe that entrepreneurial skills are leadership skills, and you can apply tech to entrepreneurship to build solutions that help lots of people. So that's why I'm really interested in entrepreneurship in that area. Um, Kind of going further into that, we also believe that high school students can learn to build successful businesses that have a positive impact around them even before they graduate. And even though that sounds crazy, I know it's possible because I've done it. So my first venture I founded when I was like 15 years old, and the goal was, this is where you come back to tech, but the goal was to help spread tech education to kids across, to kids who don't have access. Because like I noticed the same problem that you're touching on, Tanmay, which is like the conception around tech is so wrong. And I think a lot of the reason why a lot of people don't really get how creative and enjoyable tech can be is because you're just not exposed to it at an early age. You learn how to write when you're 5 years old. So the concept of writing being creative is easy. You already know how to write and you just apply your ideas and boom, you can make a song. But like with coding, there's this huge gap that most people aren't able to overcome because you're not taught to code when you're 5 years old. So when you have ideas when you're 15 years old about how you can, I don't know, like help your grandma with her disability or whatever it is, you don't know how to translate that like you can translate music. So I saw that problem and I was like, hey, I think the root here is that we're just not starting it like with really little kids. I started when I was little, and that really helped me. So I was trying to figure out how I can help bring that to more little kids. And that's what I did through high school. So I founded this thing that was able to bring tech education to over 1,000 kids. And it started kind of small, but I realized that like, hey, even though I'm young, I if I have an idea and I'm passionate about it and I really go after it, I can figure out how to make this work and how to build a team. So Startup Dojo is really taking that lesson and saying, okay, how can we take it to the next step? How can we help students not only overcome the technology barrier, but also the entrepreneurship barrier, which is like lots of kids have ideas, but they have no idea where to start, or even they don't even have the confidence to pursue it. Because when you're like a high schooler, I think I know this is true for me, but like you think that adults don't really want to hear what you have to say, and you can't really have a real impact. So that's kind of where Startup Dojo came from. It's showing young people that you are smart, your experiences are worth something, and you can solve problems and be a really big positive force.
Now, actually, one thing that as you were mentioning that, one thing that I specifically caught on to was the fact that we have these misconceptions about technology, which I mean, as I was mentioning before, but I love how you mentioned that we can solve that by introducing kids to technology and entrepreneurship as well at a much earlier age, right? Because fundamentally, both of those tasks are I mean, I think a lot of the things we do as humans in general are really creative and we just don't realize it. Technology and entrepreneurship and these things are definitely the tip of the iceberg. These are the things that, we see as, having these misconceptions but are actually really creative. But there's all sorts of things that we do that require creativity that we don't even realize. I would go as far as to say that even, as a customer support representative at a call center, for example, you are still fundamentally using creativity in the sense that you're trying to understand a problem, you're trying to, come up with not necessarily a novel solution, but a novel way to deliver a solution to a client, right? Which is why we haven't seen chatbots just immediately replace every customer service representative, because that's not possible yet. Technology isn't there. Technology isn't creative, right? That's still a human ability. But the fact that, like again, Meaghan, as you mentioned, the fact that you had these misconceptions about the world of technology before you were introduced, right? The fact that we wait so long to introduce such a fundamental life skill nowadays is perplexing, right? Like if you go on vacation to, I mean, we're in Canada, so we should know some French anyway. Not a great example. If you go on vacation to Spain, right, you're gonna want to learn a little bit of Spanish so you can at least try to interact with some of the locals, or order food or do these sorts of things. But I mean, we work with technology every single day. It's how any of our work gets done, so it only makes sense that we would want to speak its language, right? So yeah, I love what you're working on, and also the fact that you're making it more accessible for kids to actually deliver their technology too through entrepreneurship. So very, very interesting venture. We'll cover more about that as well. But now, though, Meaghan, I have a question for you, and that is that we've got two graduates on the show today, right? So you're a recent graduate from university, Anjalee, you're from high school. So Meaghan, what was your experience like during the transition from going from high school into university, which is when you were introduced to that world of technology? What was that transition like? Could you maybe describe your experiences? Maybe we could see how it sort of matches up with Anjali's completely different world of experience getting into the world of tech when she was 10.
Yeah, of course. And Anjalee, I just have to say, thank you for sharing your story about Startup Dojo. That is incredibly impressive for anyone. And just, I can't believe that you've done that much in high school already. But
Thank you
yeah,
so much. That means a lot.
but yeah, my experience with going into university, I think I didn't know what I wanted to do, but I had heard that engineering was kind of good. I loved physics. I originally wanted to go into just pure physics, so loved math, loved that aspect. Decided to go into general engineering. And yeah, I think it was a really great environment. It's definitely different because you are, at least for me, I was living on campus. I was going to all these different classes. It wasn't as structured as high school. I think my experience at University of Toronto Engineering, though, was a little bit different just because it is such a tight-knit community. And my classes, I kind of was with the same group of people every time. So it wasn't um, as like isolating as like other degrees I've heard where like you go to a class and you're in completely different classes with everyone. I was kind of in with the same group of 150 people in each class. It was actually funny, like walking from class to class. Sometimes you just see a mass horde of students go from one building to another. So in one sense, it's nice because you still have that community. You still know a lot of the kids in your class, and that kind of continued on. But yeah, I think definitely getting introductions to it. I was exposed to a lot of different people in university. Some people had experience programming, some people didn't. I think it's really funny because in first year, I remember having some friends who were just, I love coding, I want to go into computer engineering. Cool, they did it. Now a lot of them are software engineers and they're doing it. But I also had a lot of friends who were so against programming. They were not even considering programs that had any sort of coding. So they were like, I only want to go into this one stream, which mind you, all engineering programs have to have coding, but they were deciding their program based on the one with the least amount of programming.
Really?
I think, but I think what was really funny is kind of after first year, after getting more exposure to coding, a lot of these people even went into computer engineering. So I think my
Wow.
experience of being scared of programming, of not really wanting to do it, and then getting exposure and loving it, I think that's a really common experience that you get. I think most people, it's super scary. You don't know what it is exactly. It's kind of overwhelming. Like it's like any new language. When you start off, you're pretty much illiterate in that language. You can't communicate. You don't know what to do. But as you start to learn more and more, you start to enjoy it more and more because you can contribute more and you start to seek out more. I think, yeah, I went on a tangent there, but it was overall a really positive experience going into university for like the transition from high school to university. I say was very positive overall.
I gotta say that was a good tangent. Sometimes when you're trying to get across a story, you've got to go on what look like tangents to eventually tie it back to why it was important to mention it at the end. And I think that was a good example of when to use a tangent in a story. but now that we've mentioned, for example, the fact that kids were actually choosing their programs based off of which ones would have the least coding to eventually say, you know what, maybe it wasn't that bad. Right? I specifically now want to take a look at how we teach kids to code. I feel like we teach kids to code when they're young in a fundamentally different way than we do when they're older, right? Like I've taken a look at I a couple of my friends are actually in university now and are learning about computer science. There's this whole like a Discord channel with all the computer science students and everything that I sort of take a look at and sort of see what they're doing. And the one thing that I've noticed is that they learn very differently from the way that people have traditionally tried to teach kids to code. And I understand that that is important, right? Because we're not going to sit down and teach kids, how programming works all the way from, fundamental logic operators, little, the gates and how transistors work all the way up to, how objects are different from structures. Like we're not going to go, through that whole spectrum with a say 5-year-old kid. That doesn't make any sense. You want to start there with computational thinking, with logic. However, I still feel like there is a room for improvement in the way that we teach kids to code. And the reason I say that is because while it should be very simplified and while it should be focusing on logic, I feel like a lot of the ways that we introduce kids to code is very use case centric, in the sense that instead of saying, all right, we're going to build this application, now let's work towards solving these problems, going through an architecture and then writing code, rather a lot of the way that we do this, even in high schools, is by saying, all right, we're going to be implementing this game or this app, and here are all the functions you're going to need to implement, here's what all the functions are going to need to do, now go write the code. Right? We focus too much on here's what you're going to do, now go write the code, and not enough on here's how you decide what you're going to want to do in the first place. So that's actually something that I've been working towards solving in my books, like the Tanmay Teaches Julia book and these sorts of things. But I wanted to get your thoughts. Do you agree with the fact that we can sort of improve the way that we introduce the world of programming to kids and have them focus more on computational thinking and logic and that problem solving rather than focusing on the transcription of logic to code? Do you happen to agree? Anjalee, maybe we can start with you.
Yeah, I completely agree. I mean, I took CS in high school just because I liked CS and I thought that the CS course might be a good use of my time. It wasn't because you were just it's exactly what you were saying. You're just transcribing like instructions into code. So even though the course was doing a language I hadn't known previously, it ended up not teaching me anything because like it wasn't useful. You're just transcribing things. Um, so I think I completely agree. I think there's a lot more value in learning how to think through A, what you want to build, and B, how you want to build it. Because that's what you do if you decide to go into computer science, right? You're never like you're just a robot if you're just sitting there transcribing, like learning, oh, this is a class, make a class for it, and then make a game that's like very arbitrary and does nothing. And it takes the fun out of it, right?
Yeah.
So for people who are just that's their first touch with computer science, I completely understand why you would be turned off forever. Because of course, if that's your first touch, you think this is not creative, this is soul sucking, this is a waste of my time because that's what I thought. So I feel like we have to be very careful about what the first touch with technology is, and that being the first touch, it's not good.
Absolutely, right? And I feel like that, unfortunately, is a lot of people's first introduction to the world of tech, right? I was doing a workshop, I won't specify, but there was a workshop that I was doing at a school. It was a high school, and there were a bunch of different workshops I had to do that day. And, this was a high school, and so, I was talking to the computer science teachers, and they didn't know enough about the world of computer science to answer the kids' questions. And that just completely makes it disinteresting for the students. If the person you're trying to learn from doesn't understand it, you're like, if our teacher can't understand it, how would I ever understand it, right?
Right.
There's all sorts of levels to it. What about you? What do you think, Megan? Do you happen to agree?
I think I absolutely agree. I guess I'm kind of part of that generation where my first touch point to programming was in that way. I think, and I understand why they do this, but I think a lot of programming is originally taught like a math course and not like a language course. And I think again, I don't have that much experience with pure math, so it's probably a lot more creative than I think. And I'm probably going to get in trouble for saying this, but and at least from my perspective, language is a little more creative and free flowing. And I think it's easier to focus programming in a sense where you say, this is A, B, C, D. Now we're building this thing, use A, B, C, D to build F. Like that's super easy, but I think it's a lot harder. And I think it's also a little more complicated at the beginning to initially program if you teach it like a language course. But I think once you get over that initial hump, it makes it a lot more interesting and a lot more engaging. I totally love how you were talking about before, like introducing programming when you're really little. I think introducing the logic concepts kind of separate from programming is really interesting, because I think just like even the image, and I don't think this is really done too much anymore, but just thinking of looking at programming like a terminal box, like that is so scary looking. That's kind of like what my perception of programming was. But like even just like switching to like an IDE that looks a little nicer, even just starting like away from the computer, I think that's a great way to start with programming.
I think you put it really elegantly there, and also just to sort of expand upon your point. I feel like language is more stereotypically creative, whereas math is creative, right? It's a creative task, but language is what we more stereotypically associate with creativity immediately, because it's so free-flowing, right? With math, the creativity comes with, here's what I want to get across, and these are the mathematical rules I've got to use to get it across. In language, the creativity is, there are barely any rules for me to follow, right? I can do or say whatever I want, and because humans are the ones that are going to be reading this, they can use their common sense to figure it out. They can use their creativity to figure it out as well, right? Their imagination. Whereas with math, you've got to follow those rules. The only difference there is that creativity with or without rules, but the one that we stereotypically view as creative is the one without rules. But regardless, I feel like you put it really elegantly. I mean, imagine if you were teaching an English class for little kids and you were to exactly describe a story that they had to write and be like, just word this story however you want to. That doesn't make any sense, right? The point is to teach the kids how to come up with that story, to come up with the content for that essay or whatever it is that they're going to be writing, right? I mean, that's what we're doing with code today. We're not teaching it like a language class, right? We're teaching it like, maybe this isn't a perfect analogy, but like a math class, right? We're teaching them this is exactly how you would implement this application instead of allowing for a little bit of flexibility. I don't remember exactly where the study is. I was trying to look for it now, but unfortunately I can't find it at this moment. But there was a study that I was looking at a little while ago that said that in any field, really, everybody learns better when they are given a more flexible environment and they aren't told what to do. Right? So I feel like that is definitely important. All right, so I will quickly say there is a question on the live chat. All right. This is from Ravi. He's asking, and this is really interesting. I want to get both of your perspectives on this. Are further studies, so is going to like university or college, really useful? Or should I start a job at an actual company to learn more about technologies like machine learning or AI? So what are your thoughts on that?
Anjalee, do you want to take this one first?
Yeah, sure. I'll jump in. So I think there's definitely value in going to university. Of course, I haven't gone yet, so maybe I'm not the best person to completely talk about that. But I think there's definitely value there. But again, there are also people who have gone straight into like work and done fine, right? So I think like you'll survive regardless of what you choose. So if that's something you're looking into, definitely. If I have to speak from personal experience, just comparing computer science courses to real work experience, personally, the real work experience was infinitely more valuable in terms of learning than any sort of course I've ever taken, ever. Like whether that be like extracurricular courses outside of school where they were actually designed to teach you stuff, or like the ones in school which aren't too great. I can't like it's just not you can't compare. I can't compare the courses to the doing, because the doing is when you actually understand how things fit together. Like 90% of like what you're doing when you're doing this stuff is like researching and learning on the job. So like you don't really get to do that when you're just being told what to write down in code.
Yeah, and yeah, sorry, go ahead, Megan, and then I'll comment as well.
Yeah, so I think especially with programming and technology, that's one of the fields where we're starting off in university, you have the broadest range. A first year CS course has someone who's never seen code to someone like you, Tanmay, and you, Anjalee, who've been coding since they were 7, 8, 9 years old, probably younger in some of your cases. So I think you get a really broad range. I think I totally agree with Anjalee, like practical experience is super, super valuable. And I think you do learn a lot more that can apply to industry in that sense. I think you get a lot of the deep technical knowledge from courses and from university, and you can learn that on your own, but I think it's just more accessible and it's a little easier, I guess. For someone like me, it was easier to motivate myself to learn it through a course. I think the main thing right now is just with the industry, I'm not sure about just like with the future, like a lot of jobs do require a university degree. It is probably changing. The industry is like always changing. I think if you're interested in it, it helps. It's not absolutely necessary though, but I think it is, at least in terms of like requirements for jobs, it's good for checking the box.
Yeah, I happen to agree. There is definitely value, I will say, because if you look at, I mean, it really just boils down to the fact that it's just more expansive, at university or college versus, other learning media. But nothing can really replace the experience that you get actually working with tech. Anjalee, I completely agree with you. And all of the experience that I've had working with technology, every project ends up teaching me things that, I never thought that I would learn. Every new project, doesn't matter what it is. It could be something that I've done a million times before. I'll implement it in a new framework and I'll learn something new about Python that I never knew, right? So it's real experience teaches you in a way that just learning from media really can't. But what's interesting is that the expansiveness of the content that they cover in something like university is definitely many-fold greater than what you would be learning in like, high school or from an online course. So while I would say that, for taking a box, unfortunately it is, kind of necessary regardless of the kind of experience that you have. Hopefully that is changing soon and we can get more flexible, a more flexible industry. As a matter of fact, actually, another question for you specifically, Megan, from the YouTube Live chat. This is from Hrishka. She's asking, I'm learning programming in university, so I relate to Megan a lot. This is a pretty open-ended question, Megan, but she's asking, what do you think the right mindset is when you're learning programming in university?
I think that's a really great question. I think university and any time in school, it's your time to be a sponge. I think it's your time to learn as much as you can and take in as much as you can. And I think that comes from the courses that you find interesting, but it also comes from other courses. I think university is a great opportunity to learn as much as you can about as many things as you can. In university, one thing that I found that helped was reaching out to academic labs. Whether you're an undergrad, whether you're a grad student, you can always find a way to work with them. The world of academia is super, super interesting. Looking into that is super useful. And I think what I would say for that is just to try to kind of expand and look everywhere and try to learn everywhere, because there's so much to learn in university that aren't just from your specific degree requirement courses.
Mm-hmm. Thank you for sharing. And Hrishka, if you have any other questions from here, please do feel free to put them in the YouTube live stream and we will go ahead and answer them as well. All right, so now another question. This is from Shiva. This one will start with you, Anjalee, but also I'd love to get your thoughts, Megan. She's asking, how does technology help in increasing productivity during the course of doing business? And there's another question, but I'll ask you that one in a moment. But first of all, how can technology help us increase productivity during business?
Yeah, I think this kind of relates to themes we've been touching on throughout the entire conversation. But I think, like you mentioned this, Tanmay, which is like everything we do in the world is based at least partially or largely on technology, right? Right now we're all working remotely and literally everything we do is with technology. So to answer like how does technology help with productivity in business, I think like being proficient in the technologies you're using, whether that be, I don't know, Zoom or anything else, knowing that and knowing how to get around that is really helpful. And also in terms of like a more in-depth perspective, like if you're asking, how does coding maybe help with productivity? How does me knowing that help with productivity? To answer that, I think it definitely does, because if you understand how the system you're working on works in different angles, it'll be much easier for you to like problem solve or troubleshoot when you have a bug in like a meeting or in whatever else you're doing with your business. So like just having that background knowledge gives you a really intuitive understanding how everything works. And because so much of our lives now depend on technology, especially in the business world, it's really important to develop that intuitive understanding.
Mm-hmm. Yeah, I feel like actually what you mentioned there is something that's almost funny. I forgot exactly what we were doing, but some time ago, me and a friend were doing something, and we were doing something that was pretty graphically intensive, if I remember correctly, and it had like really interesting animations to it and stuff. And I remember saying, and the friend that I was doing this with wasn't really that deep into technology. I mean, he started sort of coding, but wasn't really doing it very actively. And I remember that it was almost hard for me to really concentrate or have fun on whatever it was that we were doing, because the programmer in me was thinking, how would they have implemented that? Right? I was like, I was almost getting anxious, like that is so detailed and so complex. What exactly would be going behind that? And just trying to figure out, like, for the sake of my own curiosity, what could they be doing behind the scenes to enable something like that to happen? So you're right, when you learn technology, you almost have this drive of trying to figure out how and why things work. And you can infer a lot of that, actually, when you have experience, just from the way things interact with you, right? Just from the way that, for example, Slack interacts with your mouse, you can probably figure out that it's an Electron app and not a native app. And that's something that, to the average user, you never tell the difference apart from PowerDraw. Apart from PowerDraw, you never tell the difference. But then as a developer, you look at that and you're almost immediately like, that's an Electron app. and that can help you in so many different ways as you use the application to increase productivity, right? So I love what you mentioned, Anjalee. It's about getting that intuitive understanding for technology that can help you increase productivity in really anything, right? And maybe even a good example is automation. I was in Slovakia a little while ago, and my mentor there, William Carbone, he was talking about how, in Slovakia, there are literally jobs for people in the shipping industry where all they're doing is copying and pasting shipping numbers from one page to another. That's it. That is their job. And imagine how much time we could be saving, how many man hours we could accumulate to other fields like education or healthcare or art if the people behind that knew like a couple of lines of Python code to automate that. so that fundamentally comes in. Anything you want to add, Megan, to that?
I completely agree with everything you guys have said, Anjali and Tanmay. I think the point about technology being very useful both from like a personal perspective, so knowing how to use the software, knowing how to do it, to just giving you better and broader knowledge about the business as a whole is super, super valuable. I think overall we're trending towards more and more tech, so it helps you out in all aspects. Yeah, I totally agree with everything.
Wonderful. Also, really quickly before we get to Shiva's next question, I do want to take up another quick question. This one's from Swandeep. They're asking, I want to know, how can we use Python as a tool to develop AI? Really quickly, I will say, just as a quick note, that if you're looking for Python resources in specific, you can go to an online website called cognitiveclass.ai, where they've got all sorts of different resources for learning about machine learning and Python and programming in general and all that sort of stuff. Although I would recommend that if you're a beginner getting into the world of AI and machine learning and you have the option, do actually try to use, you might want to give a try to Swift for TensorFlow and the Julia programming language, which are sort of like the future of machine learning and AI. I do have a course on cognitiveclass.ai on Swift, and of course there's my book on Julia as well. They are the next generation of programming languages that are eventually, soon, going to help us get rid of Python for more complex machine learning jobs. So, soon. But regardless, anything that you want to add to that, Anjalee, Megan, any resources that you know of to learn about AI, machine learning, Python, these sorts of things?
My experience with AI is I haven't really dabbled much in it, so I'll defer to you too.
I think, I think depending on where you're looking from, Coursera has a great selection of courses. I think it's like the Andrew Ng courses on machine learning. I think it's like the Yale one or the Stanford AI courses are really good. Those can get a little technical, but if you're willing to spend some time I think that's really helpful. And then as always, you can find so many fun projects that you can kind of modify for your own. Even following along to one can be really interesting just online. Lots of random Medium ones that are really good. I think Medium is a great tool to find stuff. And I think for courses, Coursera is kind of where I tend to look.
I will say one of my favorite fun examples of machine learning, which actually, the reason that I like this example so much is because it's almost fascinating enough in a way for when I would go to a workshop or do these sorts of things. Whenever I introduce people to this specific example, they're like, oh, that's really interesting. And that interests them enough for them to want to go through the effort of wanting to learn machine learning and AI. Mm-hmm. And that example is Google Deep Dream. I actually have 2 videos on the channel about Deep Dream. This is some of the images that you can generate with Deep Dream Tech in my in my Julia book. But there are 2 other videos on the channel about Deep Dream, and I think it's a really interesting example. So thank you for sharing that, Megan. There's also the more technical courses on like Coursera, the ones from like Stanford and so on, that you can use as well. So hopefully that answered your question, Swandeep. Okay, so next up we have another question from Shiva. What technologies do you find really exciting, and what technologies do you find that are life-saving, so that save people's lives, and which ones are your favorites?
Um, okay, I can jump in. So one really cool thing that I'm really excited about right now is like UAVs, unmanned aerial vehicles. So on my podcast, I recently had this really cool guest. He's CTO at this awesome like Toronto-based startup called SkyX, where they're trying to build unmanned aerial vehicles to right now they're trying to monitor long-range assets. So like think pipelines, railroads. Normally for things like that, you have to pay people to trek out into dangerous conditions and drive alongside like these really treacherous things to make sure that there are no leaks, nothing wrong that's happening.
Mm-hmm.
But right now they're trying to just apply unmanned aerial vehicles, which are like little drones with some like good software on them to just monitor it. And you can save so much money and get such a broader and more deep understanding of what is happening. And it's around the clock. So that maybe that use case is a little boring, but I'm more excited about that use case, that tech, because they're also working on a ton of other cool things. Like Jason mentioned how there was like a person who went missing in the neighborhood, like a child. So they just lent out their drones to help search for that. So there's so many cool things that can happen in terms of like the future, like shipping, so many cool use cases for unmanned aerial vehicles.
Yeah, very nice. That's really quickly, just before I sort of pass it over to you, Megan, so you can also answer the question. One thing that I want to mention is you said specifically that while the use case might not be that exciting right now, the technology has a lot of potential. I feel like I've encountered that exact conversation with a lot of people many times. Like a couple of I forgot exactly when the event was, but back like I think 2 weeks ago, when Apple held their event for the watch and the iPads, and they announced the A14 system on a chip. That A14 chip is one of the first processors in the world to be a 5 nanometer process. So they're bringing it down from 7 to 5 nanometers for the transistor size, right? And they are able to get way more single core performance, fit more cores into the package, less power draw, all these sorts of amazing features and advantages, and better neural engine, better GPU, all these sorts of architecture, pointer authentication for security, all these different things. And people ask me and they're like, why is this so interesting? And what I say is that while this tech may not inherently be interesting, what's interesting is that it can power other technology that is, like UAVs, for example. Instead of them having to send data over the cloud via 5G type technology, why not just put something as powerful as the future rumored Apple A14Z on something like this so that it can compute on the edge, right? These sorts of innovative technologies enable these sorts of innovative use cases. So love that example. Megan, what about you? What are some exciting use cases of technology that you've seen?
I think both like the exciting and also the most like powerful or life-saving. The one I'm thinking of a lot is kind of just like data science and how you can apply that. One example with the kind of how you mentioned interesting use case that can be applied on something else. When you think of the most popular kind of like image processing kind of project, it's like you look at a photo and you say, is it a cat or is it a dog? Yes or no. And you seem like that seems really basic, but when it's applied to medical imaging, that's when it's really, really powerful. I think where the most life-saving can come in with medical imaging, with helping out with medical studies, being able to help pinpoint and catch certain diseases in a scan that maybe even the human eye can't detect. I think that is super, super interesting right now.
Right. I feel like it ties back into our little discussion about machine learning technology. I mean, right?
I think you're the expert on that.
Well, but what I'm trying to get at is that with machine learning, we're no longer sitting down for like 5 years as a research team writing all the rules to determine if an image contains a cat or a dog. So what people should realize is that when we build a cat-dog classifier that's powered by generic machine learning, the best part is we didn't write the rules for that. So we could literally the next minute swap out the cats and dogs for skin lesions with and without melanoma, and suddenly we've got an image classifier that detects melanoma, right? So, of course, there would be little architectural changes that would, specify the network to find, smaller features in a lower resolution image, these sorts of things. But generally, the rules are written by the computer now, right? So that's a really interesting use case. That's where visual recognition is getting us. All right. Now, another question. This one's actually a bit more specific to AI, machine learning. We'll. I'm wondering if we should face this one. Okay, actually, we'll get to that one in a moment because I want to spend a bit more time on that one. First, I'm going to ask you another question from Shiva. This one is, what's the most challenging time you've ever faced working with technology? Have you ever gotten really frustrated? And if yes, how have you eventually made that exciting for yourself? So, either one of you can answer that first. Think about it. What's the most challenging time you've ever had working with technology? While you think, I would say one of the most challenging times I've ever had working with technology was this one time. There was a really low-level compiler project I was working on at IBM, actually, and our code base was meant to instrument code within another really, really, really large code base, like 30 million lines of code. And the instrumentation would inject code from the compiler into the really large code base. And what turned out that we were getting Stack Overflow errors whenever we would run with the instrumentation, and the reason for that was because our code that we would inject would actually call out to an overloaded operator within that same code base. But because it was within that code base, it also had that line of code, which was infinitely calling itself. That took a week and a half to debug. So there have been some really frustrating times, but it was worth it in the end because we built some really good call tracing utilities with that. But what were some of your most challenging moments with tech? Anjalee, maybe start, or Megan, start with you. Megan.
Yeah, I think kind of similar to yours, just working with a lot of data. As part of my final fourth year capstone project, we worked with the Canadian Sports Institute Pacific, and for that we helped detect jumps for professional snowboarders. To do this, we had little IMU devices in the boot of snowboarders, and we collected data and analyzed it after the fact. An IMU device is just an inertial measurement device. So basically, you get in 3 different types of data points in all 3 axes. So you have accelerometer, gyroscope, and magnometer. I think analyzing all of that, I think the hardest part with that was just kind of getting a starting data set in terms of none of the data really aligned, and also in terms of detecting jumps. We were shown what a jump looked like, but we didn't actually have any label data sets. So I think for us, how we were working at it, and I'm not sure if this is right, but this is how we decided to go at it, is kind of manually labeling the data, which was very time intensive, and with big files tended to crash our laptops, which we were using. So I think just like that was definitely an interesting learning experience. But I definitely have a lot of respect for how many large labeled data sets we have now, because working to create your own is definitely very time consuming and stressful.
Gotta say, I'm also very grateful for the folks that are releasing these large labeled data sets for us to use. I mean, there are just some that are incredible, right? That you wouldn't believe a data set of that scale has been released. Unfortunately, there are some issues with like copyright and stuff that makes it so some data can't be released. But anyway, that's a totally different issue. But yeah, thank you for sharing. That is the right way. You would have to manually label data. That's just kind of what you got to do. But again, it really depends on what your goal was. But you could use services like Figure 8 actually, which would let you send all of your data to them, and they have a bunch of folks that sit down and label data for them. So there's all sorts of things that we can do today. But open source data is really good. Akash has another question about that. But first, Anjalee, what was your most challenging moment working with tech?
I think I can definitely think of a lot of like just small, silly issues where it's like, oh, we merged something and then something underground goes horribly wrong and it takes us like a week to figure it out. Like so many examples, like the one you mentioned earlier, Tanmay.
Yeah.
But in terms of like a bigger, maybe better example for a story, I can think back to my robotics team. So I mentioned how we developed this system that we use to position ourselves because if you're just relying on any other method, it can be very accurate, it can be very inaccurate and allows for lots of error to accumulate. So when we built the system, building the system wasn't enough. First, after we had that system, we couldn't get it to accurately work until we figured out how to actually develop movement algorithms so that it would get to a place and get there accurately. So a lot of the time you'd overshoot or undershoot, and like you have to deal with like when you're dealing with hardware, there are lots of fun issues like I don't know, like slippage, and it's like there are lots of engineering hardware problems that you have to deal with too. So like trying to compensate for that and find the middle ground of like, okay, how do we make this as accurate as possible, both on the software side and on the hardware side, and figure out like break it down into hardware and software pieces and then attack it. So from like the developing accurate movement algorithms, but also cooperating with hardware and being like, okay, no, this piece hardware should make it better. This piece hardware should make it better. So like that was like a continual challenge we faced, and it just took for lots of continual development.
I can I can imagine that would be frustrating to work on. Actually, personally, I will say one of the reasons that I specifically, prefer to focus more on software than actually integrating with hardware is because then we can focus on the logic. I'm not a front end guy. I don't like working with, UI and that even extends a lot to hardware because, then you can focus more on the problem solving and the sort of logic when you get to work on the back end. But there have been some projects where that's just not possible, right? You've got to interface with hardware in some way. One of which was this project where I had to get electrocardiogram data from a mobile device to my code, and this is actually really funny. There's this application called the AliveCore, and basically what they do is they sell you this little device. It's powered by like a 3-volt button cell, and you hold both ends of it with two different metal strips, and then it emits a really high frequency audio that encodes your electrocardiogram, and then your phone's microphone picks it up and decodes. It's high pitched enough that you don't hear it, but your phone hears it, picks it up, and decodes it. Because why use Bluetooth, right?
Yeah, so cool.
So I had to get that. I was like, you know what? If they can decode the audio, so can I. And me and my friend spent like 3 consecutive days and nights actually manually looking at a spectrogram of the audio that this thing emitted and trying to decode the exact spec of the electrocardiogram. So working with hardware, especially hardware that you don't build yourself, can be incredibly annoying, but it's worth it in the end. And the reason I mention this is because at the end of the day, this was only possible for us to build in such short notice for a demo, for a keynote, because of open source technology. Without the prior documentation of a lot of this technology and a lot of these different audio filters and such on GitHub, we have a lot of these implementations. We re-implemented it from scratch, but that's a different story. Without that logic being open sourced, we couldn't have done that. That would have taken us months. Which actually leads me to Akash's next question. He's asking, what are your views on contribution to open source contributions to open source or being part of the open source community? So what are your thoughts on open source tech for the both of you?
I think like we touched on this earlier, but like I think it's really really valuable because there's so many problems that are just they're much easier to solve when it's open sourced. So now you can have people like Tanmay who are just trying to figure out a specific use case, but because all this other stuff is open source, now you can implement it for your specific use case. And if that wasn't the case, then Tanmay wouldn't have been able to make that thing, make that app work, and then lots of other people wouldn't have been able to do it either. So open source is super, super valuable. And I think it's awesome if you are like interested in contributing to it and moving that forward. It's so valuable to the community.
Absolutely. And Megan, any other thoughts?
Yeah, I think I completely agree with everything you guys have said. It's really great to contribute to open source. It's really kind of driven our our faster development in technology these days, and I think it's a great way to get some experience. And I think it can be very fun. You're part of a global community. I think if you're interested in it and you want to do it, go for it.
Wonderful. All right. Yep, open source technology is way more useful than a lot of people would think. Literally everything we do is powered by open source in some way, right? Everything we do is somehow powered by like a Unix kernel at some level. Even if you're using Windows, some inspiration was derived by Linux Unix kernel. So open source is everywhere. But I digress. Next question, actually set of questions because these two are pretty related. Um, Someone's so on YouTube we have a question from Bhavya, who's asking, I want to learn programming and go into technology. How can I do that? Can someone help me? But we also have a question from Vignesher, and they're asking, as an adult, where do we start with learning technology? Because there's too many. Actually, they're saying there's too many resources and it's confusing. And so let's answer both questions really quickly, just so I will say. We have already covered a few resources, right? So like we've already covered Coursera, Cognitive Class. I think these are really valuable resources that you can use to learn about the world of technology. And of course, there's different books and YouTube channels that you can go to learn about the world of tech as well. But I do want to ask you, Anjalee and Meaghan, first of all, what do you think we should say to both Bhavya and Vignesher as to how someone can learn programming and what you would specifically give advice for adults? So we've talked a lot about students and kids, but how does that differ for an adult that wants to learn about the world of tech?
Yeah, in terms of like maybe some resources we haven't listed yet. So we mentioned, so there's also Udemy, Udacity, Code Academy, all great resources for like how to learn specific technologies or coding languages. Um, but maybe on the question about how can adults learn it, I think the advice there is to really focus on like implementing things, because I feel like when you're older and you're trying to get into it for the first time, it can be very daunting to just pick up like a C book or a book on C++ and read through it and then write your first line of code. It's gonna drive you insane, because it's gonna be like this whole new world of things that you've never had experience with before. So my advice there is to just focus on things that are like courses or instructional things that are more project based, and then get to writing code. Then you'll start to feel much more comfortable much faster.
Hmm.
Hmm.
Very nice
I
advice. And Meaghan?
I completely agree with that. I think if you're absolutely new to coding, I think there is some value to taking just like a basic introductory course. It makes you a little more familiar with the terminology and what to do. But I think from that, just pick a passion, pick something that you want to do. I think one piece of advice that was given to me about personal projects was to find something that you like to think of a product or think of an application that you want in your life and to build that. So whether it's something to help you with your scheduling, or whether you like sports and you want to make an application for your next fantasy football league or something, like make something that you want. And I think that really helps motivate you to do it. And the best learning experience is really just through doing it and trying it, just like Anjali said.
Wonderful. I agree. Learning through doing is always the best way of learning because it's what gives you real experience. And when you're implementing something you're passionate about, you have that drive, right? You have that motivation to want to implement what it is that you're doing. I mean, I for one, maybe a good example actually of a project that was pretty long term. I think maybe a year and a half. And it wasn't something that I was working on actively, every day for a year and a half, but it was something that came and went for a long time. Actually, I didn't realize it, but this relates to my cognitive class course. Back last year is when I published that. And for that, I had to build a game playing AI. So I did a little bit of research into 2048, which is a game that a friend of mine introduced me to a few years back. And it was an interesting game. Didn't seem like many people had made machine learning or AI systems for it. So I built one and put it in. And it was one of the fastest 2048 AIs that you could get. And it had a pretty good win rate, something like 93%, 60 moves a second, not bad. A year later, I come back to it and I'm like, there's definitely scope for improvement. This can be made way better. So, because I was so almost annoyed that there wasn't enough research into 2048 AI, And the reason I was so annoyed is because 2048 is a stochastic game, right? Every time you play it, it's going to be different. You don't know where tiles are going to be placed. You can't just have a strategy. You have to be able to deal with error. You have to be able to deal with the fact that, oh, a 4 came in a really bad place. How do we deal with it, right? So I was so annoyed that there just wasn't enough research there that I spent another week, went into the profiling, got it to a maximum of 8,000 moves a second from 60, and also increased the win rate to like 97%, right? So as long as you're passionate about something and you're like, you have the motivation to want to do it, right? And there was so much that I learned from that project that I would not have learned if I wasn't working on it, all the way from how to solve cache invalidation errors in Swift to all these sorts of things. And learning from that experience is really, really something that you can't replace. So hopefully that answers your questions. Again, feel free to put more in the live chat if we can expand. Another quick question from Saisley. We did already cover a little bit of this, but maybe if we want to be more explicit with this one, Saisley's asking, can you tell us why we need to study programming and computer science? Really quickly before I hand that over to you, I will say, just to sort of make the wording a bit more clear, you don't need to. Right? This is not something that we're saying you absolutely must do. I mean, I, for one, am of the camp where, you should be doing what it is that you're passionate about, not, what people say you should be doing. But regardless, what are some reasons that people should learn about programming and computer science? Anjalee, Meaghan?
Yeah, okay, I'll start. Why should we learn computer science? I think that's such a good question. I completely agree with Tanmay in the sense that I think you should do what you're passionate about. But if I'm trying to convince you as to why you should do it, I think what I want to say is that computer science is more than just understanding the language. Computer science is amazing. Programming is amazing because of the use cases you can have if you understand it. So I think, personally, I'm really fascinated by the intersection of tech with other fields like businesses and social sciences and history, and figuring out how we can use this technology that I now understand to solve problems in these intersections. And I think that is something that I'm personally really passionate about. So for other people who are maybe you think, or who may be really interested in something, whether that's I don't know, the humanities or a specific social science problem, anything that you would imagine would be the furthest thing from technology, a lot of the time technology is a tool that you can use to solve issues in that field, in that domain you're really, really passionate about. So I think no matter where you are, it's really valuable to understand tech, because then you can start seeing the connections and how you can apply these ideas and these concepts to actually solve problems for people. So I think that's my advice.
And Meaghan?
So why should you learn programming, technology?
They're saying programming / computer science. That's the exact wording.
Why should you learn programming? I think everything Anjalee said is incredibly true and super valuable. I guess not to repeat it, another good thing, we've kind of touched on this before, is just the opportunity for automating, even if you're in something completely different. Even just knowing a little bit of Python, a little bit of scripting, it can help you make your day a little faster, help you with your everyday things. I think, you can go at it from 2 points, just from the purely learning, problem solving, kind of the more fun side, or just the practical side. You can make your day a little faster.
Right. The little clicks that you save really add up over time, right? Being able to automate things is definitely a highlight. And also just the problem solving that this technology teaches you. There's all sorts of advantages to being able to learn about the world of programming and computer science. Computational thinking, problem solving, creativity, all these sorts of things. All right. Let's see. There is a question from Ayash, actually, this time. He's asking, this one's a bit more technical. I'm not sure if you would have anything to add here, but in case you do, there's also NVIDIA cores with GPU accelerated texture compression. What are your thoughts on that? Do you do anything with texture compression on NVIDIA GPUs? No, so
I think that's a little out of scope for me.
Yeah, that's a little out of scope. But Ayash, I have a little bit of experience working with NVIDIA technology. There are two tutorials on the channel about this sort of stuff. I will also link to that after this. I do not talk about the texture compression. I only talk about CUDA kernels in these. But now that you've mentioned it, I will create more tutorials on these sorts of things. I'm not sure if you meant to talk about the texture compression or more like AI related things like the tensor cores, but regardless, that's out of scope for this episode. But I will do more. Actually, it would be interesting to do a GPU compute focused tech life skills episode. We might do that in the future. Good, that's a good idea. All right. So now, there is a question from Soren Deep that I'll go ahead and answer with a more AI specific angle, but I'm going to generalize really quickly so that the two of you can also give your thoughts. He's asking, how can AI and machine learning technology be connected with different fields like education and hospitals? What are your views on that? But I'm going to generalize that to, how do you believe that we can use like cutting edge technology in fields like education and healthcare to enable better outcomes? So maybe we can start with you, Meaghan.
Yeah, education, healthcare, both great fields to work on. I think technology can be used and applied in both education, healthcare, from the teaching aspect and also just to help apply it. I think healthcare is a little more intuitive. We're already implementing lots of interesting technology with that. And then, yeah, I think from the education aspect, just improving the experience. I think we've definitely realized with everything going on Zoom classes that there's a lot we can do when it comes to online education and the technology that's related to that.
Mm-hmm. I agree. I mean, education specific is the one example that I think we all sort of point to because,
Yeah.
a few days before everything transitioned to Zoom, you tell anybody in the field of education that this is how we're going to do things in a few days, they would say, no, you're crazy. That's not how we're going to do it. But then a few days later, suddenly everything switches because, we're being forced to change, and thereby we are presented a good opportunity to innovate due to COVID. So, things are changing. Also, one more thing that I wanted to quickly mention as part of the previous question that was asked by Cecily as to why we should learn programming computer science, just before I hand this question over to you, Anjalee, is one more thing that I noticed that I just quickly want to mention is that technology isn't its own industry, it is infrastructure. And people really don't, I feel like people underrate the value of infrastructure. Like, for example, in the Netherlands, they have the infrastructure to be able to support the vast majority of their population bicycling to work every day. And because of that, they, produce way fewer greenhouse gases. They're working towards their goal of, not having to emit any CO2 from cars, right? And they can do that because they have the infrastructure. In the U.S., they don't have nearly as much public transportation infrastructure in any capacity, which is why we've got people like, Elon Musk working on that, the whole Boring Company thing and the Hyperloops and these sorts of things. And that's because, we've got to get infrastructure. I feel like the word infrastructure is boring, but it's actually really exciting. So technology in itself is infrastructure for everything else we do to work. So it's like innovating at the very bottom of the stack leads to innovation everywhere on top of it too. So learning technology is important in that aspect. But yes, now I'd love to get your thoughts on Sorendeep's question too, Anjalee. How can we use technology in different fields like education and hospitals for better outcomes?
Yeah, I think first of all, I'd like to say that the infrastructure
Yeah.
word to describe technology, I think that's spot on. Like I couldn't have said it better. Tech is just infrastructure that we can use everywhere else. And if you innovate at the bottom, there'll be innovation at the top. Precisely. Yeah, I completely agree with that. And in terms of like how can we use tech to get better outcomes in fields like healthcare and education? I mean, oh my God, the list goes on and on, the potential use cases. Like earlier I mentioned, like we were talking about ML earlier and how you can use that to spot melanoma or whatever else. So there's so many different use cases for how it can innovate. And I think education is also particularly interesting because of this whole COVID situation. Exactly like you two touched on, where it's like we never would have thought we could go completely online, but now everything is completely online.
Yeah.
So it shows us that when we are forced to innovate, we can. And because we have tech and that a lot of certain infrastructures in place through tech, we were able to handle this transition decently. Like Zoom existed, Google Meet existed, and we were able to handle this and complete like that rapid transition overnight because we had this infrastructure in place. So I think like in terms of how can we make it better, how can we improve outcomes, I think it's really just understanding the value of infrastructure and putting more time into like, okay, what are some specific issues that we have in education? How can we innovate from the ground up to make it more effective? Like how can we actually personalize math education to students? I don't know. There's so many different problems, like domain specific problems that you can try and solve and build out the infrastructure for it.
You're right. The comes back to technology being infrastructure, right? That's I feel like that's a key to all these questions. So thank you for answering that. There are two more questions which are a little bit more technical, slightly outside of the scope for this episode, but I'll just cover them really quickly. Saurabh asks, actually before I answer that question, I'm going to ask the two of you, what are your favorite programming languages? Anjalee.
My first programming language was C, and then I went to C++. So let's stick with like C++.
All right.
Or Python.
All right, C++ and Python. And Megan?
I started with C as well, so I transitioned from C to Java to Python. I think Python is definitely my favorite language right now.
Interesting. Okay. So Saurabh asks, can we use JavaScript for machine learning? I believe Akash let him know that there is TensorFlow for JavaScript. Usually you only use JavaScript for inference. Please don't use JavaScript for training. That's not what it was meant for. JavaScript is an interpreted language. It's not very high performance. It's not built for these sorts of things. The most that it was ever really built for was making web pages interactive. Now, unfortunately, a lot of people have tried to put JavaScript on the back end as well with Node.js and these sorts of things. But yeah, we should be using real back-end languages for back-end development. So let's not train with JavaScript, but for inference, absolutely, that is totally an option. Another question quickly from Byte89 asks, imperative or declarative programming, can we compare which is better? My personal perspective as a compiler guy, both. Because my perspective on this is always how can we give the compiler most control so the programmer doesn't need to do as much, because compilers are way smarter than humans because thousands of humans are building them versus a single human building a single program. Best example, which is why this is my favorite programming language, is Swift. If you want to be imperative and you want to declare everything from scratch and you want to use all different C functions and you want to do no arc overhead, feel free to do that in Swift. You can write really verbose code. You can basically write C in Swift. But if at the same time you feel like you want to just write some slightly lower performance but really easy to read code in a declarative way, then you're free to do that as well. Whereas, with Python, you're stuck with duck typing, which is just do whatever and Python handles it, which is really good for convenience, but then not so good for performance. And as a compiler guy, that kind of hurts. I would say that both is always the best way to go. And whenever you have languages that are just one, you see a lot of people complaining. C and Go and Java, pretty much imperative. You have a look at Python, which is mostly just declarative with the capability for imperative, which people also complain about from a performance angle. So both, I think, is the best of both worlds. All right. And also, Kaushik asked, what's your favorite programming language? You two have already answered. I've answered Swift, Julia, and it would be a tie between C and Kotlin for the next spot. So those ones. All right. There is one more question, and this is going to be, I believe, our last question for the day, but we'll see if anybody has any other questions. Feel free to put those in the live chat. And this one's from Akash. He's asking, what are your views on making kids self-taught for learning programming rather than making them rely on teachers, like you taught yourself? Okay, so how about rephrase his question. What about having kids learn by themselves instead of having to learn with teachers? I will say there's an interesting perspective to that I'm going to share, but first I want to ask you, Anjalee and Megan, what are your thoughts on that?
Um, Self-taught versus being taught. I think there's definitely like merit to both approaches. I think the value in being taught is that a lot of the time when you're young, when you're like 5, 6 years old, you're not going to get exposure to like what is programming unless somebody else, normally an adult, shows you. So I think there's a lot of value there in having teachers introduce, especially young kids who have no idea what this field is at an early age. Because I think there's, for most people, unless your parent's a programmer or something like that, you're just not going to get that introduction. In terms of being taught, also tons of value there because you, like as we touched on earlier, I think you definitely get the most learning value from just doing your own projects. So like I've learned the most from just doing stuff and failing and making mistakes and then learning from it. So like definitely merit to both approaches, and I think in the ideal world, there's a mix of both.
Wonderful. I totally agree. It's all about that hybrid, right? It's
Yeah.
not about just having kids learn on their own because that's not particularly effective either, right? What motivation do they have to continue to learn unless they're already incredibly passionate about it? And who do they have to sort of guide them along the issues that they find? But at the same time, just being told things and being taught things also isn't particularly effective. I feel like it goes back to Megan's point about teaching it like a language class almost, where you're not saying, here's an exact story that you need to write, right? That
Yeah.
we're not going to teach language that way. We always teach language as come up with a story, come up with your ideas. So teaching programming that way, I think, is more effective. But Megan, anything you want to add to that?
I think self-taught versus being taught, yeah, especially when you're younger, I think there is some teaching aspect that I think most kids would really benefit from. But self-teaching yourself, I think just teaching yourself the building blocks, the basis to do it, and then kind of letting people run with their own projects, at least for me, would be the ideal way to do it. Kind of touching on our individual versus group work. I think this would be a perfect use case for group work. So again, I'm biased. Most of my courses were formatted this way in school, and this is how I learn best. But it's having like half in class, half teaching, and then the other half working with groups of 4 or 5 others to create and build something. I think that's kind of my ideal learning format. And I think how it would work with younger people as well.
Wonderful. That's really interesting. It's really interesting to hear both of your perspectives, especially since you're at different stages. Megan, you started learning programming in university, and you've had a couple of years of experience. And you just graduated, and Anjali, you've been working with it since you were like 10, and now you've graduated high school. So it's interesting to see your perspectives on this and how they match up and how they differ as well. So thank you for sharing. Really quickly, another question from Anj. This is not a question necessarily, but you mentioned that Node.js is high performance language only if you include Express and Node mod. Quick note, that doesn't make the language high performance. That means that the web server package you're using itself is high performance. So Node.js is still a pretty slow language for things like AI training. Like, you're never going to use Node.js for that. Those are high performance web servers. Also, Python doesn't just have templates, they also have protocols. Sorry, they also have classes. If by templates you mean protocols or interfaces as they're called in Java. Apart from that, really quick question from Sai. Again, unfortunately slightly outside of the scope of this episode. Can you tell me what the future of reinforcement learning is? Even though it's currently in its infancy stage, should we learn reinforcement learning? I would say it's a really interesting field. It enables machine learning to do a lot of things that we couldn't do with regular supervised or unsupervised learning. But unfortunately, I don't want to take up too much time of this episode talking about that. So I will have, for sure, there's actually a new sort of series of videos that I'm working on where I will be covering all sorts of different AI topics, including reinforcement learning. Make sure you subscribe if you want to learn more about that and get notified when I release those tutorials. But that's coming soon. Stay tuned for that. All right, really quickly, I believe those were all the questions, although people are really liking this episode. People are really excited, and if you have any more questions, feel free to go ahead and put those in the comments, and we can go ahead and answer them after the episode as well, in case we weren't able to get to your question today. Another question that I see is, what 3 languages would you recommend for machine learning? We've already said Python, Julia, and Swift. Python for the fact that it's already the standard, Julia and Swift for the fact that they are the future. All right, well, that brings us to the end of today's live Q&A. I don't see any other immediate questions via the live streams. But I must say, those are really good questions. I absolutely loved getting your perspectives on these different, topics and different issues. I mean, thank you very much for sharing all of this. And actually, now, before you leave today, would you like to share a closing message with the audience? Maybe we can start with you, Anjalee.
Yeah, sure. In terms of a closing message, yeah, I think we had a number of questions come in about like getting started in programming and the importance of it. So to kind of like close up on that thread, I think like if you're interested in it, or even if you don't know anything about programming or coding or technology, make like just start dabbling, start playing around with it, because I'm sure you have problems in your life or problems or things you're passionate about where technology, this infrastructure, can be applied to help make it so much better. So that's one message. And my other message would be, I think it's really important that young people especially start trying to take advantage of tech and this cool infrastructure to not only just small problems for yourself, but also problems for other people. And I think that's why I'm so passionate about the intersection of business and technology, where you can apply your knowledge in like, I don't know, your experience building applications to help other people. So I think that's really cool. And for people who are interested in entrepreneurship and the intersection of business and tech, definitely check out my podcast, The 2020 Show, and Startup Dojo at mystartupdojo.com.
Definitely. I will go ahead and put the links to the 2020 show as well as Startup Dojo in the description. So do take a look at that, everybody. And also, Megan, what would you like to say to our audience today?
Yeah. What I would like to say to the audience is just thank you for listening. And also just it's never too late to start programming. And I would just like to add a little message that it's never too intimidating. I think if you have any inkling of just like being curious about technology, explore it, look into it, and just really see what you can do. Apply it to something that really that's really important and valuable to you, and try to just work on that. I think really just technology is so amazing, and it unlocks so much. Just try to think of not what technology or not what you can do for technology for what already exists, but how you can apply technology to something pre-existing that you already love, and it'll just help you become more passionate about technology if it already relates to something you're passionate about.
Wonderful.
Yeah,
So,
thank you.
of course, glad to have you both on the show. Kind of flipping the quote: "Ask not what you can do for technology, but rather what technology can do for you."
That was kind of on the fly.
Yeah, no, but
I
that
don't
was.
know if that makes sense.
I think it does. I think it does. It's all about. I mean, it actually goes back to what Anjalee was mentioning in the beginning of the episode, right? It's all about not necessarily technology for the sake of technology. It's technology that we can use to make our lives better, to augment our capabilities, right? That's what it's all about at the end of the day. The A14 chip means absolutely nothing if it's not put in an iPad or if it's not put in, something that makes it useful. I mean, the ARM architecture means nothing if it's not powering UAVs and enabling, us to do all these sorts of amazing things. So I absolutely loved the thoughts that you shared today. Thank you very much. I do know that the two of you are busy, so thank you for joining. Megan, I know you're in the middle of moving and stuff, so thanks for joining. This was an incredible episode. We've covered all sorts of different things, and I think you've really put into words more elegantly than I have ever thought of it when it comes to how we need to teach people to code. We've got to teach them like it's a language class, right? Not like math, not like other things where we can just say this happened or this is what should happen, but rather come up with these ideas, do it yourself, right? That's what technology is about at the end of the day. It's about the creativity. So I'm gonna be using that example from here on out. Wonderful. So once again, thank you very much, Anjalee. Thank you very much, Megan, for joining me on the show today. Thank you very much, everyone on the stream, for joining. These streams are held every Sunday in the morning Eastern time, 11 a.m. Make sure you join us next week as well. We've got some really interesting content with someone that I've been working with, a really good mentor of mine. So make sure you join us next week. It's going to be a super fun episode. We're gonna have a lot of fun next week. So yes, all the links that I promised will be in the description, including all the different tutorial links, cognitive class, Anjalee, your links, and also contact for both Anjalee and Meaghan will be in the description within around 24 hours once the replay processes on YouTube, and we will answer any questions that we weren't able to get to in the comments as well. So thank you very much once again, everybody. This was a really exciting episode, and goodbye.